Hi everyone, Assalamualaikum. In this video, we are going to continue with example 2 for population growth or bacterial colony under applications of first order ODE. A population of butterfly in the garden grow at a rate that is proportional to their current population. If there are initially 300 butterflies in the garden and in 2 weeks' time the population becomes 500, estimate number 1, the population after 1 month, and number 2, the doubling time for the butterfly population. Alright, to solve this problem, first we need to extract all the information and write T for time and P for population. Alright, so we check one by one. Okay, if there are initially 300 butterflies, okay, so initially means T equals to 0 and then population equals to 300, right? 2 weeks time means T equals to 14 days, alright? Alright, and then become 500, okay? So we can write P equals to 500, okay? And then estimate number Roman 1, the population after 1 month. Okay, so we can write T equals to 30 days. Okay, we assume 1 month equals to 30 days. Okay, and then we need to find P. Okay, right, because estimate the population here. Okay, and then number Roman 2, estimate the doubling time. Okay, doubling time means we need to find T when P equals to 600. 600 here means double from original P. Okay, original P equals to 300. So after we double, we have P equals to 600. Alright. So this is from the word doubling time. Right. Alright. From D population over D time equals to K population. Okay. We separating variables time and P. Okay. So after we separate, we get this. We move over dt to right hand side. So we get times dt. And at the same time, we move P to left hand side. So we get 1 over P dP. Okay. After that, integrating both sides. Okay. From this equation, we just put integration symbol for both sides. Then we integrate left hand side and right hand side. Okay. So after we integrate, we get this. Okay. To integrate left hand side, we can refer, let's say, if we want to integrate 1 over x dx, the answer equals to ln x plus c. So now we have variable p. So if we integrate 1 over p dp, the answer should be equals to ln p plus c. But we just put plus c on one side only. Okay. And to integrate right hand side, let's say we have integration of 2 with respect to x. The answer equals to constant 2x plus c. Now we have integration of constant k with respect to time. So the answer equals to k time plus c after we integrate. Right? And after we integrate, no more integration sign. Right? Now we need to write p as a subject. Okay, so we move ln to right hand side. So we get p equals to, when we move ln to right hand side, we get e. Okay, we get index base e to the power of kt plus c. Right? Or we can write p equals to e to the power of kt plus times e to the power of c. We split. Okay, using the properties of indices. If we have a to the power of m times a to the power of n, the answer equals to a to the power of m plus n. So from here, we reverse this formula. So that's why we get this. Alright. And e to the power of c, we can write equals to c. Okay. because E means Euler number, which is equals to constant 2.78718 something. So constant to the power of constant will equals to constant. That's why we can write C only here. Okay, so we have P equals to CE to the power of KT, right? Then we can name as equation 1, right? From the previous slide, we get P equals to CE to the power of KT and we name as equation 1. Okay. Then we can use the first information to find C and the second information to find K. Alright. To find C, substitute T equals to 0, P equals to 300 into equation 1. Right. So from equation 1, P equals to CE to the power of KT. Then we replace P equals to 300 and T equals to 0. 0 times K equals to 0. Right? And E to the power of 0 equals to 1. So C times 1 equals to C. So we get C equals to 300. Right? After that, we substitute the value of C into C in equation 1. Right? Then after we substitute, we get this. P equals to 300 E to the power of KT. Right? We substitute C equals to 300 into C in equation 1. So we get this. Right? After that, we can name as equation 2. Right? Then, to find K, substitute T equals to 14 days, population equals to 500 into the latest equation into equation 2. Right? So from equation 2 here, we replace T equals to 14 days. Okay? And we replace P equals to 500. Okay? After that, we get E to the power of 14K equals to 500 times 300 here. We move to left hand side, we get over 300. Okay? Right, now we want to find K. Before that, we can simplify 500 over 300 equals to 5 over 3. Okay? Alright, to find K and K here in exponent, so we need to move E to right hand side. Okay? When we move E to right hand side, okay, we get 14K equals to ln, okay, 5 over 3. Okay? After we move E to right hand side, we get ln. Okay? Then K equals to ln 5 over 3 over 14. Okay, then we get K equals to 0.03648 up to 5 decimal places. Right? Right, after that, we substitute the value of K into equation 2. Okay? So we get this. Right? P equals to 300 E to the power of 0.03648 T. Okay? We substitute K, the values of K here, into K in equation 2. So we get this. Right? So now P equals to 300 E to the power of 0.03648 T. Then we can name as equation 3. Equation 1, 2, and 3 are the same equation. Equation 1, we write in terms of C and K. Equation 2, after we substitute the value of C. And equation 3, after we substitute the values of C and K. And this is the population at any time T. Right? From the previous slide, we get an expression for the population at any time T is given by P equals to 300 E to the power of 0.03648 T. And we name as equation 3. Right? So, we can answer question Roman 1. We use this information and we substitute into equation 3. Okay? So, substitute T equals to 30 days into equation 3. Okay? So, from equation 3 here, we replace t equals to 30. Okay? And then, using calculator, we get P equals to 896.21691. Okay? This is an estimation value. Alright? Population means we need to write in whole number. So, we can write there are 896 butterflies after 1 month. Okay, 1 month because 30 days. Alright? Right, this is the answer for question number Roman 1. Right? Alright, after that, we can continue for question number 2. Okay? Substitute population equals to 600 into equation 3. Okay? So, from equation 3 here, we substitute P equals to 600. Okay, and then we have equals to 300 e to the power of 0.03648t. Okay. Then we have e to the power of 0.03648t equals to 600, and then 300 we move to left hand side, so we get over 300. Okay. Then we get e to the power of 0.03648t equals to 2. Okay. 2 here because doubling time here. So we get back 2 because double from the original value. Alright. Alright, then to find t, we need to move e to right hand side. So we get ln here. Okay. So left hand side we have 0.03648t equals to ln 2. Right. Then using calculator, t equals to ln 2 over 0.03648. Okay, which is equals to 19. Okay. Since we use unit days for time, so we put this here. Okay. So we can write thus it took 19 days for the population to become double from the original population. Right? So this is the final answer. Right? It took 19 days for the population to become double from the original population. Right? Coming up next, more examples involving applications of first order ODE. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.